Hello everyone and welcome back. We are glad to announce the release of Rhino.Inside.Revit GPT Assistant. This assistant is designed to solve very common problems that many users face every day. We have noticed these issues repeatedly on the forum and inside the community. Many users ask the same questions again and again, especially around components, workflows, Node in code, and Python scripting. Before diving into the demonstration, let's quickly look at the challenges users commonly face and how this assistant is designed to help with them. First, many users do not know whether the right component exists for a specific task. They often guess, search randomly, or build workarounds without realizing that the correct tool is already available. Even when a component exists, users struggle to find it in Grasshopper and to understand the inputs and outputs, especially when some ports are hidden or optional. Because of this, components are often connected incorrectly. This leads to unreliable Grasshopper workflows and unexpected behavior in Revit. Another common challenge is Node in code. Users are unsure when it should be used and how it fits into a real workflow. They do not know which references are required, how to write the correct component names, or what the correct order of inputs should be, because all of this directly affects execution. Custom Python scripting adds even more complexity. Users are unsure which assemblies to reference, when a transaction is required, and how to convert geometry correctly between Rhino and Revit. This is exactly why we decided to release the Rhino.Inside GPT Assistant. This is an initial version, and we will continue improving it as we go along, based on real usage and feedback. The goal is simple: help users work faster, build correct workflows, and reduce unnecessary trial and error. Now let us go through a few examples and see how this assistant works and how it supports you during real workflows. Let's start with a simple and very common example. Here the task is, I want to modify the view range settings of an existing floor plan view in a Revit project. Is there an official Rhino.Inside.Revit component for this? And where can I find it in the Revit tab? The assistant immediately confirms that an official component exists. The component is called view range. It also tells us exactly where to find it in Grasshopper. The category is Revit, which corresponds to the Revit tab. The subcategory is View, which represents the view panel inside that tab. Next, we see the description of the component. This description is the same one you will also find directly in Grasshopper, so there is no ambiguity about what the component does. Below that, the assistant lists all inputs and outputs in the correct order. This is important because the order matters when building workflows and when using Node in code. In this case, the inputs expect a view and several level-based elevations. These correspond to the top, cut plane, bottom, and view depth of the view range. The outputs return the same view together with the evaluated level elevations. This makes it clear what data the component consumes and what it produces. This is a good example of how the assistant helps you quickly confirm that a component exists, where to find it, and how to use it correctly without guessing or trial and error. Now let us move to the next example and look at another common task. This time related to parameters. The question is whether there is an official Rhino.Inside.Revit component that can change the parameter group of an existing Revit parameter, and if so, what the component reference is. As we can see, the assistant immediately returns a relevant component. In this case, it points us to the parameter identity component. This is helpful because it removes any guesswork. We are being routed directly to an official component that is meant to deal with parameter identity and related metadata. Now the real value comes in the next step. If you ask the assistant to explain this component in detail, it returns much more than just the name. It shows the inputs and outputs in detail along with the hidden options. It suggests a typical workflow that is known to work. It also highlights limitations, common mistakes, and practical tips for using the component correctly. This is what I call the secret sauce. Because instead of just finding a component, you also learn how to use it properly in a real Grasshopper workflow. One important note is that this detailed explanation is currently available only for selected components. If you ask for a detailed breakdown and receive nothing, it simply means that this feature has not been added for that component yet. Now let's continue with another example and look at how the assistant handles unsupported requests. This GPT targets only official Rhino.Inside.Revit components. If a component is not part of the official build, it will tell you clearly instead of guessing or suggesting unreliable workarounds. For example, if we ask I want to place bolts in a Revit project, is there a specific Rhino.Inside.Revit Grasshopper component for creating bolts? The assistant checks the official component list. If no such component exists in the current build, it responds with a clear message. There is no official Rhino.Inside.Revit component with this name. This is important because it saves time and removes confusion. You immediately know that you need a different approach, such as a family-based workflow, a structural connection workflow, or custom API scripting, depending on the requirement. Now let's move on to workflow guidance. Here, instead of asking for a single component, we ask the assistant to guide us through a complete Grasshopper workflow. For example, we can ask, I want to filter the specific wall type associated to a level 3. Which Rhino.Inside.Revit components should I use and how should they be connected? In this situation, the assistant does not just list components. It suggests a clean and reliable workflow that matches how Rhino.Inside.Revit actually works. For workflow questions like this, the assistant typically provides four key things. It lists the required components and where to find them in Grasshopper. It gives step-by-step workflow guidance. It provides a connection diagram that shows how components should be wired together. And it includes notes that highlight limitations, common pitfalls, and data structure considerations. As we can see in this example, it outputs the correct components for the task. In some cases, it also provides obsolete components so you can explore alternatives when needed. Now let's move on to Node in Code. Let's start with a simple question. I have an adaptive family loaded in my Revit project and I want to place instances using Grasshopper. Which Rhino.Inside.Revit component supports this? In this case, the assistant will route you directly to the correct official component for placing adaptive components. The assistant starts by providing the component name, description, and the full list of inputs and outputs in the correct order. This is the key point. Before we jump into Node in Code, we can first confirm the official component and its port order. That gives us a reliable reference. After that, we can ask the assistant to generate the Node in Code version of the same component. As we can see, it uses the correct references and clearly shows which inputs need to be provided. It takes care of the core requirements, so you do not need to rely on trial and error. Now let's ask something more specific. Generate the node in code to analyze Revit walls and extract only their orientation output. Here you can see that the assistant adjusts the output index because orientation is the last output of the analyze wall component. This shows that it understands the exact output order and how to retrieve a specific result. The more specific you are about the query you want, the more precise the node encode result becomes. You can also generate node encode for multiple components and chain them together using outputs from one component as inputs for the next. Now let us move on to the last part, which is custom Python scripting. Here the quality of the result depends heavily on how specific your request is. If you know the exact Revit API method you want to use and mention it in the prompt, the script will be more reliable. If not, the assistant will look for a stable and commonly used API solution and build the script around that. Now let us ask the assistant to generate a Python script that extracts all wall face references and converts each referenced face into a Rhino brep. As you can see, it uses only the relevant references and applies geometry decoder to convert Revit faces into Rhino geometry. Next, we ask it to generate a Python script that creates a linear dimension in Revit. Here the assistant switches to geometry encoder because now we are converting Rhino geometry into Revit compatible geometry and using the appropriate Revit API method with correct transaction. So the core idea is simple. When geometry moves from Revit to Rhino, it is decoded. When geometry moves from Rhino to Revit, it is encoded. The assistant applies this logic automatically based on the task you describe. That brings us to the end of this introduction. As you have seen, the Rhino.Inside.Revit GPT Assistant supports you at every stage, from finding the right component to building correct workflows to generating node encode and finally to writing reliable custom Python scripts. This is not a finished product. It is an evolving assistant that continues to grow based on real usage and real needs. And while it may make mistakes, it is designed to improve over time. We encourage you to use it in your daily workflows. Test it with real problems. Ask precise questions and see how it fits into your way of working. If you feel something is missing or if there is a feature that would make your workflow easier, let us know. Your feedback and feature requests will directly shape future improvements. Thank you for following along, and I look forward to seeing how you use this assistant in practice.